So rebar is absolutely vital to any structure that is related to concrete. The steel is what carries the majority of your weight, and that's what the design is based upon. This is just a standard grade 60. 60 means that it's 60,000 PSI on a yield strength calculation. That's calculated based on how many pounds it's able to carry divided by its original area, surface area. So the bigger the diameter bar, the larger the area, therefore the larger the load it's able to carry. This rebar is typically placed in your tension zone or the underneath side of any concrete slab to give it the extra stability for whenever that load is being carried. The material wants to flex downward, and that steel is placed to keep that bridge deck from sagging and permanently deforming. This giant specimen here is what they consider an anchor bolt. This is used to hold down lighting masts, those big steel masts that hold your lights over your major intersections. These actually go down into concrete, and they have a hook on one side, and they're bolted that base plate to the base of the concrete. These markings here are going to help us determine our elongation of our specimen. So what you'll see as the bar goes through that plastic and elastic stages of its deformation, you'll actually see the specimen elongate with the more stress that is applied to it. So basically what we're doing here is we're measuring our original specimen length. After we pull it, we'll put it back together and see how long it's deformed, and you can use that calculation to determine your strain. What we're testing for is ultimate tensile strength and ultimate strength of the material. That way they can use this in design to calculate how many bars they need to place on what their structure is.